Have you ever wondered how your GPS calculates the shortest route to your destination? It's not just random guesswork. It's a clever application of a mathematical concept known as the minimum spanning tree. This concept is a gem from the treasure trove of graph theory. Minimum spanning trees are used extensively in our everyday lives, especially in technology. Next time you're using your GPS or streaming a video, remember that there's a minimum spanning tree working behind the scenes. They help in designing efficient networks, ensuring that data travels the fastest way possible. But these trees are not just confined to technology. They also play a critical role in fields ranging from biology to computer science, helping us to solve complex problems by finding the most efficient routes or connections. Now you might be thinking, what exactly is a minimum spanning tree? Well, let's dive deeper. Imagine you are in a maze with different paths, each with a different length. Your goal is to cover all points in the maze with the shortest possible path. In the world of mathematics, this maze can be represented as a weighted connected graph. Picture it as a collection of points which we call nodes. These nodes are connected by lines known as edges. Each edge carries a weight, symbolizing the length of the path it represents. Now, let's add a twist to our maze. We want to visit every single point, but still want to keep our total path as short as possible. This is where the concept of a minimum spanning tree, or MST, comes in. A minimum spanning tree is a subset of the graph that connects all nodes, ensuring that the total weight of all the edges is as small as possible. Think of it as a roadmap that allows you to visit every node in the graph, while keeping your total travel distance to a minimum. It's like planning a road trip where you want to visit several cities, but want to keep your total driving time as short as possible. In essence, the MST is all about efficiency. It's about finding the most effective way to reach all nodes without any unnecessary detours. It doesn't matter how many paths are available, the MST will always find the shortest possible route that covers all nodes. But remember, this doesn't mean that the MST is the shortest path between any two nodes. It's the shortest path that allows you to visit every node in the graph. This is a crucial distinction to make, as it's easy to confuse the two. So, we have understood what a minimum spanning tree is, but how do we find it? This is where Prim's algorithm comes into play. Prim's algorithm, named after computer scientist Robert Prim, is a clever procedure to find the minimum spanning tree in a graph. This algorithm is a journey of discovery, where we start from a single node and gradually expand our reach by adding the shortest possible path at each step. Imagine you're standing at the base of a tree, with branches spreading out in all directions. Each branch represents a path, and each path has a certain weight or cost associated. Your task is to climb this tree in such a way that you touch every branch, but your total climb should be as short as possible. That's what Prim's algorithm helps you achieve. So how does it work? Let's break it down. We start from any node, let's call this our starting point. From here, we look at all the edges that connect this node to others. Out of these, we choose the edge with the smallest weight. This becomes the first edge of our minimum spanning tree. Now, we have two nodes in our tree. We repeat the process, but this time, we consider all the edges that connect these two nodes to the nodes not yet in our tree. Again, we choose the edge with the smallest weight. This process continues with each step expanding our tree by one node. There's one rule we always follow. We never create a cycle. This means that we never add an edge that connects two nodes already in our tree. We only add edges that bring in new nodes. This ensures that our tree remains a tree and doesn't morph into a network. This step-by-step approach continues until all nodes are included in the tree. By this point, we have our minimum spanning tree. It's the shortest possible route that covers all points, achieved by always choosing the smallest available step. And there you have it. By using Prim's algorithm, you have found the shortest possible route that covers all points in your graph. So, let's quickly recap what we've learned today. We've explored the relevance of minimum spanning trees in real life, understanding how they provide efficient solutions in networking, transportation, and even in genetics. We've also delved into the concept of a minimum spanning tree in a weighted connected graph, a key element in understanding complex networks. Finally, we've uncovered how to find this tree using Prim's algorithm, a simple yet powerful tool. Remember, mathematics is not just about numbers. It's also about finding the most efficient ways to solve problems, just like what minimum spanning trees do in real-life situations.
Want to rise to your full potential in your studies and revise like a boss? You can trust Study Guide today to have you covered. Subscribe to this channel and see our website linked in the description of this video to see revision articles to maximize your study gains.